I'm Zachary Cartwright. This is Water in Food. Welcome back to another episode of Water in Food. Throughout most of our previous episodes, I've had the opportunity to speak with a range of food producers and food scientists and discuss how their success is connected to controlling the water in their products. So far, we've learned about fruit snacks and chocolates, mushroom jerky, nutraceuticals, pharmaceuticals, even hemp and cannabis. And throughout these episodes, we've briefly touched on some of the technology that is used to measure the water in these items. Now, after each episode, I've been receiving a lot of questions about the available technologies to measure water activity and moisture content. And to help answer some of these questions and to learn more about some of Meter Group's products, we decided to bring back our friend, John Russell. John is a field sales specialist at Meter Group, and he was featured back on episode 4 of the podcast. So definitely go back and listen to that episode to learn about balancing stability and continuous improvement. John has been selling water activity meters at Meter Group for quite some time. We'll have to ask him the number of years. And there's no one else with his level of expertise when it comes to knowing the equipment and what is available to measure the water in food. So with that said, welcome back to the podcast, John.
Thanks, Zachary. Glad to be back.
Yeah, we're glad to have you. Well, what's new with you? What's changed since the last time we spoke with you?
Well, I've had my COVID shot, so I can actually get out in the community and do what I want to do again. So that's been nice.
And where are you located, John? Where are you based?
I'm in New Jersey, Somerville, New Jersey.
And overall, how are things there where you live?
Well, things are fine now. It's nice. Summer's coming back. We're fully open, so we can go into stores and restaurants, and employees still wear masks, but the rest of us are free to roam maskless now.
Well, good to hear. I'm glad things are slowly returning to normal. I thought it would be really helpful for our listeners to have you back on and just to hear about our instruments. You know, you can go online and you can look, or you can set up a meeting with me and get really technical. But sometimes I think the best way to learn about these instruments is just to listen to a conversation. And just like the previous podcasts, we interview people and really try to focus on the story. And I'm hoping that you have some stories associated with each of the pieces of equipment that we'll go over today. So let's just start with some background information, and maybe you can just provide your definition of water activity and how it compares to moisture content.
Sure. Water activity is the measure of the energy status of water in a system. So unlike moisture content is the amount of water. But some of that water gets bound in chemical bonds, capillary bonds, or there's solution effects. And that water, the water molecules are all like buzzing around with a certain amount of energy, and that energy goes down. It slows down the water molecules with that bonding. And so the overall energy is lower. Now, when it comes to moisture content, it's a measure of how much by percent weight. And so it's just a measure of how much water. It's actually very surprisingly difficult to measure. But water activity is not difficult to measure. And you get so much more information because it's that energy of water that affects chemical, physical, and biochemical reaction rates over time. So things like whether or not you're going to have microbial growth, how water moves from one component to another, if you might see lipid oxidation or Browning reactions, enzyme activity. All of these things have to do with the energy of the water and not with how much water there is.
And what would you say are kind of your top 3 reasons for using water activity? It sounds like maybe the ease of use, the accuracy, but what would you say are kind of your top 3 reasons to use water activity instead of just moisture content?
Oh gosh, one of the top ones is process control. Water activity, because it is so much easier to measure, you get much more consistency in the results that you take, but it's also a much smaller measurement. So I liken it to measuring to the nearest millimeter rather than measuring to the nearest inch. So if you can do a quick test as you're processing, whatever the product is that you're working with, especially if there's a dry down process involved or a change in moisture in that process happening, water activity is just going to be a much easier way for you to ensure that you're following the same process every time, bringing that product to the same moisture level every time.
And has the use of water activity, is this something that's been around for decades? Is this something relatively new? I know you've been in the field for quite some time, and I'm just wondering what you've seen in the food industry or pharma industry. Who uses water activity?
Gosh, it's used in many, many different um, uh, um, applications and different market segments. So, of course, for pharmaceutical stability of pharmaceutical products is very important. Same with food. Anything with a product that needs to be stable, water activity becomes relevant. And so we've actually the most of the research of about water activity came about in the 50s. Our company has been making water activity meters since the mid to late 1980s. I think 1987, our first water activity meter was released and sold to the food industry. So the food industry is where it was most important at the time to make sure that there weren't chances for microbial growth. And it's a great way to mitigate microbial growth and so to keep your food safe. And so that's what really built the knowledge around water activity in foods was that interest. But as people learn more and more about water activity, it becomes more and more known that it really affects the overall stability, whether that be chemical or physical degradation, whether it be how much moisture is absorbed through packaging based on the vapor transmission rate in the packaging. All of these things have to do with water activity. So we've got building materials, we've got adhesives, cannabis, like you had mentioned earlier, and cosmetics. These are all industries that are using water activity, and they're at different levels of understanding about the water activity. And so traditionally, many of these industries have used moisture content and found that it really doesn't give them the information they need. And with water activity, you get a much better idea of what's going on in your products.
So it sounds like people who are concerned about water activity include food scientists or R&D teams and quality control teams. Definitely the consumers, they want a safe product. Who else cares about water activity? What about people like shareholders or people interested in business value associated with this measurement?
Oh, great question. Like I was mentioning earlier for process control, Um, if you have a better way to get precise, accurate results in your moisture levels while knowing that it's going to maintain the quality and safety that your customers need and want, you can actually increase the yield. The way you increase yields and the profitability is by adding more moisture, but knowing that it's safe. The challenge with moisture content measurements is that the moisture content measurements just aren't precise enough. And so you will tend, or what companies tend to do, is dry more than is necessary, lowering their yield, often lowering the quality of the product because it changes the texture and the mouthfeel and a variety of other things. And so if you can increase the moisture to have the most optimal amount of moisture for profitability while also being safe and high quality product, then of course shareholders care about that. I mean, we have some, you mentioned cannabis. Easily, we are increasing revenues by over $1 million for the cannabis industry for companies. There are other industries. Look at jerky. Jerky's a really good one. We all have opened up a package of jerky, and sometimes it's way too tough. And sometimes you get that really nice, moist jerky. Now, if we can do that, keep that really nice, moist jerky, but keep it safe, your customer is much happier and the shareholders are much happier because it's so much more valuable. We actually did have We did have a jerky company that we worked with, and we implemented some of our systems for the rapid measurements of water activity with automated electronic data capturing. They raised their revenue by $546,000 in just 6 months. So, I mean, it makes a huge difference.
And you touched on it a little about how you're measuring water activity, but what are the different sensors that are used, and are some sensors better than other methods?
Oh, well, there are definitely different types of sensors, and it depends on your application.
Mhm.
So, when you're measuring water activity, what you're really doing is you're taking a sample and you're putting it in a small closed system. And it's a natural phenomenon of thermodynamics that water will move from high pressure to low pressure till it comes to equilibrium. If you can imagine all those water molecules buzzing around, they all want to feel the same amount of pressure, and so they spread out until that pressure is equal. What that means, in a small closed chamber where you put your sample, the water molecules will move from the sample material to the air and from the air to the sample until there's equilibrium, and then we're testing vapor pressure over top of the sample. So the question is, how do you test vapor pressure? And there are a variety of different ways. There are, humidity sensors like capacitance sensors. Other electrical sensors can be used where you're testing electrical properties, which aren't really a measure of vapor pressure or of humidity, but they can be calibrated to mean something in terms of humidity. And so or to water activity. So you tend to see less accuracy. You tend to see greater chance of shifting calibrations and so forth if you use an electrical properties sensor. Now, if you have a chilled mirror dew point sensor, we find it's really, really stable. So the way a chilled mirror dew point sensor is you're chilling a mirror till a dew forms on the mirror, testing the temperature of the mirror and of the sample at the time that the dew forms on the mirror. And it's very highly effective. It's the most accurate way to test water activity, and you get very good consistency. But there are times when that is not the best method, and those times would have to do with those uh, um, volatile ingredients that might be in your products, things like ethanol, propylene glycol, um, essential oils. These are things that are highly volatile, and those volatile vapors can settle on the mirror. So we actually have a device called the AQUALAB TDL. It stands for tunable diode laser. With the tunable diode laser, the laser shines across the headspace, and it's been fine-tuned so that it only is interfered with. That laser only notices the water molecules in the air and is not affected by any volatile vapors at all. So really, if you have volatiles, that's the best way. Using the tunable diode laser is going to give you consistent, accurate results. It's also nearly as accurate and consistent as the dew point sensor, but you can test all products regardless of the ingredients.
And that's a perfect pivot because I want to touch on each of the pieces of equipment that we offer. And let's just start right there with the Aqualab TDL2. So I'll ask you the same three questions to start about each instrument. And that's the type of sensor, the accuracy of that instrument, and how long it takes to get a reading. So tunable diode laser, it's using a laser. But what is the accuracy of the TDL2, and how long is it taking to get that reading?
Great question. So TDL2, like I mentioned, you can test all of your products regardless of contents. And the accuracy is plus or minus 0.005 water activity. And most of your products will take about somewhere between 3 to 5 minutes. Some can take a little bit longer. For that equilibration process to happen, like I was describing earlier, you do have to wait for full equilibrium to get that accuracy of 0.005. However, the TDL2 can connect to our Scala software, and we've actually been able to develop this just in the last year and a half, where we can use machine learning to learn that equilibration process for a given product. So for any given product, that equilibration process that happens in the Aqualab sample chamber, that small closed system where you're putting a sample, that's consistent. And the Scala software can learn that and then can calculate an algorithm. After just 3 full-length reads, it can calculate an algorithm and give you a reading in just 60 seconds. And highly accurate, not as accurate as 0.005, like the full-length read, but always better than 0.02 water activity and often better than 0.01 water activity. Still get really good consistency and accuracy even with a 1-minute reading using that artificial intelligence piece in the Scala software.
So some of the pros for this instrument sounds like the ability to essentially run any type of sample, even if volatile components are there, the speed. Are there any other pros that you would put with this instrument, maybe compared to our other instruments at Meter or instruments made by other companies?
Yeah, so the real one of the real pros, I mean, this is what designates it against all other equipment on the market, is that you don't have to worry about what volatiles. I mean, we already brought this up, but there's no other water activity meter that can test any product, regardless of volatile content, without the use of some filters. You have to get the right filters, or without the concern of, say, a polymer in the sensor absorbing volatile vapors, or like I mentioned with the mirror. So that's the number one designating factor. You get high accuracy, and it doesn't matter what the ingredients are. You can connect it to the Scala software and have automated data collection assigned to product, the batch, the technician taking the test, date and time. All of that data can easily be collected. You can do that with our other equipment as well. But with AQUALAB TDL, it's a very smooth transition connecting it and getting all of that data. Very easy to do and a user-friendly software.
So lots of pros, but are there also any cons? Are there any drawbacks that you see about this instrument?
I wouldn't say that there is a drawback. The price is higher, the technology is more expensive,
Mhm.
and so we're not able to build the equipment for the same price that we can build the others. So it is a higher price tag, but the added value is there as well. I mean, especially if you can use it to increase your yields, and you know that you've got correct data, so you know you're getting having products that are safe, and not worrying about whether or not you're getting incorrect data.
And what types of customers are using the TDL2? Who do you sell this to?
Flavor companies, fragrance companies, very, very popular in those industries. Pharmaceuticals, especially when working with organic solvents or topical pharmaceuticals, cosmetics industry, the toothpaste and oral hygiene products. These are all industries, and also cannabis. Cannabis is highly volatile, and a lot of the products, cannabis itself doesn't necessarily need a tunable diode laser, but a lot of the products, essential oils, and products where terpenes are added, like with gummies and so forth. These are things that you really need the TDL, and there's no other meter on the market that can give you the accuracy that you can get with the TDL.
And is there a customer story that stands out, either about the TDL, the old version, or the new version, the TDL2? Anything that comes to mind about this instrument and a client that you've worked with?
Um, yeah, so here's an example. Essential oils is a good example. So I was working with a client who needed to test the water activity in essential oils, and that's their specialty. And the question was, can we use a capacitance sensor? The capacitance sensors are much less expensive. And so, that's a little bit desirable, but not if you're getting faulty readings. And so I actually did some testing. I had some tea tree oil in my medicine cabinet, and I pulled it out, and so I did this testing myself in my home office here, comparing the different kinds of sensors: a dew point sensor, a capacitance sensor, and a tunable diode laser. The dew point and capacitance sensors both gave irregular readings that were elevated. The capacitance sensor was too high, not as high as the tunable as the chilled mirror dew point sensor, but those electrical property sensors, the volatile vapors get into the polymer, and it really throws off those readings sometimes. And I was seeing that effect with the capacitance sensor. So the only way to get accurate readings was the tunable diode laser. So that was fun because I was involved in doing a bit of the testing and experimenting myself to make sure we were able to provide the best equipment for our client, the client we're partnering with, in making sure that they have the equipment they need.
And I know our listeners can't see it, but there's a TDL2 right over your left-hand corner. Is that right?
That's actually the TDL1, but I do have
Oh,
a
I see.
TDL2 right here.
Oh, there it
This
is.
is a
Well,
TDL2. Yeah.
you have I'm sure you have the
I could
entire
show you, but I
collection.
think the video's not on. So.
Well, let's move on to the next device. Let's just move on to the AQUALAB 4TE. So same three starting questions. What type of sensor is in this instrument? What is the accuracy? And how long does it take to get a reading on the 4TE?
Yeah, the AQUALAB 4TE uses a chilled mirror dew point sensor. It's accurate to plus or minus 0.003, has a very consistent calibration. Readings are usually between 3 and 5 minutes. There are some products that will take longer, and it has to do with adsorption, desorption rate of a given product. So products that are very high in oils or fats might take longer. Products that are very, very dry, say down in the 0.1 water activity range, will take a little longer as well. But for most products, by and large, it's between 3 and 5 minutes. The AQUALAB 4TE is our tried and true. It first was released in 2009. It's still being sold today. And it's got the temperature control needed to do temperature abuse studies. You've got the accuracy that your R&D team needs. You've got really good consistency. So it's a great instrument to have.
And what does the TE stand for, John?
The TE stands for temperature. So there was a day when we were making equipment that didn't have temperature control, which means that if you're using any equipment, and this is true if you were to buy a portable meter or a meter from another brand, there likely will be no temperature control. And water activity is actually temperature dependent. So at different temperatures, you will have different results for your water activity tests. So it's really important that not only you have good temperature control, so your sample is close in temperature to the sensors when you start taking the reading, but also because you want to know that you're getting consistency in your results, and you're not seeing variation just based on changes in temperature, ambient temperature changes that will affect the results that you're getting.
And as far as pros and cons go for this instrument, what would you say?
Pros, gosh, the accuracy is phenomenal. Ease of use is phenomenal. The one downside is that it doesn't it's not as effective if you have certain volatiles like propylene glycol, ethanol, other organic solvents, essential oils. These are things that acetic acid. Those are the kinds of volatiles that you might see less accurate results with when testing with a dew point sensor. So it really is important that you are aware of what sensor is going to work best with your for your applications. And so that's really the only downside. The other downside is that the hardware isn't equipped, even though it can connect to our Scala software. The hardware isn't equipped, so it's not able to do the 1-minute readings using that machine learning piece with the Scala software. We can do that with the AQUALAB TDL. We have another device, the AQUALAB 3, that are able to give those 1-minute readings, and the 4TE is not designed to do that.
And we'll touch on the AQUALAB 3 here in a second. just to finish off the 4TE, who uses this instrument, maybe the types of clients, but also within that company, where is this instrument? Is it on the production floor? Is it in a quality lab? Where would we find it?
Definitely in your R&D lab, commonly used in quality labs, frequently used on a production floor. Um, it, uh, um, it is more of a lab instrument where it has a clamshell lid that could let, if you're in a dusty environment on the production floor, then I would recommend a different meter. But I have seen many on a production floor as well. So it really is a very universal meter and can be used most anywhere. It's just a question of, are you looking for those fast readings with automated electronic data so you can really increase your yield while also being safe? And for that, it's not the best fit.
So AquaLab 3, this is our last piece of equipment that we'll go over today. So same 3 starting questions. What are the sensor or the sensors in this instrument? What's the accuracy? And how long does it take to get a reading?
Yeah, AquaLab 3 actually has a dual sensor. It uses both the chilled mirror dew point sensor and a capacitance sensor. The chilled mirror dew point sensor is accurate to 0.005 in the AquaLab 3, and the capacitance sensor is accurate to 0.02. So the capacitance sensor can work with some volatiles, like if you're less than 3% ethanol, works well with propylene glycol. There are other volatiles that it might struggle with, like the essential oils. If you have organic solvents or alcohol above, about 3%. It varies depending on how the volatile is bonding with the rest of the system. It's not an exact percentage, but it's able to handle both of those. And actually using the two in combination, that enables us to get 1-minute readings with the AquaLab 3.
So pros here, the reading time and being able to connect to Scala. Well, any cons here associated with the AquaLab 3?
So the only con would be if you have a higher volatile content than what would be good for the capacitance sensor. It doesn't have the temperature control between 15 and 50 degrees Celsius the way the TDL and the AquaLab 4TE do, so you wouldn't be able to, say, do temperature abuse studies, for example.
Mm-hmm.
So it does have those limitations. It does require that you're connected to the Scala software, which is a cloud-based software, and it's remarkable. And that's what gives the most value. One of the things that I am able to see giving really high value with the 1-minute readings for products that would take 10, 20 minutes in a 4TE, like ghee, for example, or lard, sunflower seed butter. Um, these things would take a long time to get a reading, even with a dew point sensor or a tunable diode laser, until you connect it to the Scala software, and then we can still get that accuracy of better than plus or minus 0.02 in just 1 minute.
And something that we haven't touched on too much yet, but can you also get a moisture content reading from the AquaLab 3 or any of the instruments that we've talked about?
We absolutely can. So, and this is actually your expertise, Zachary, but what we do is we make a moisture absorption isotherm for a given
Mm-hmm.
product. And it's amazing how consistent many of these moisture absorption isotherms are. For example, kibble, we see even from many different brands a correlation with that moisture absorption isotherm curve being very similar. Um, and so a moisture absorption isotherm, what is it's a graph or a table that shows us the relationship between water activity and moisture content. And different products will have different relationships, and those relationships are not linear. It would be nice if they were. It would make things much easier, but you're going to see a difference in the shapes of those slopes. that if you're looking at a graph, but with the moisture absorption isotherm curve, you can learn that relationship, and then if you have an easy water activity reading, minimal sample prep, non-destructive, you can also get the corresponding moisture content. What that means is you can know both your water activity and your moisture content, and when connected to Scala, then you can get that moisture content, but you can also get your 1-minute readings if you're using the AQUALAB 3 or the TDL. So it works with all of our equipment as long as you're connected to the software, because for those isotherms to work, you need, the equipment needs to know what product is being tested. So we can create a moisture model, a mathematical representation of that isotherm curve, load that into the product where we designate the product in the Scala software. And so then every time you read that product, you'll see both the water activity and the moisture content.
And what type of customers are using the AQUALAB 3, and where would this be found? Is this another R&D tool, quality, on the processing floor? Where does this instrument go?
Sure, it absolutely can be used for R&D, but it's really designed for quality and production. So it's designed around, and for AQUALAB 3, you have to be connected to the Scala software, and that's what makes it really so special and so unique, because it's fully integrated into the Scala software. And so with that full integration, uh, people who are working in industries where having that process, like they're wanting to know that they're drying to the same dryness every time, they need that fast electronic feedback to do that. So that's a really common one. When you have a lot of throughput, like if you're in a lab that is just receiving tons of samples, then having to wait even 5 minutes for each of those samples, it really limits how much you can do in a day. So being able to have that fast throughput is really helpful for labs as well, and to not have to write down the readings and then later transpose it into Excel. If that's just part of taking a reading, um, then it really speeds up all your processes. It removes so much human error.
Now, all of the models and instruments that we've discussed so far, they're current technologies, and this has resulted from decades of research and development at Meter. And I'm curious to know, in your opinion, what have been the biggest innovations in water activity readings during your time at Meter Group?
Oh, I'd say a year and a half ago when we came out with the 1-minute readings.
Hmm.
The other one was the tunable diode laser, which was around 2014, 2015 that we developed that. Using the tunable diode laser in the AQUALAB TDL enables us to test products that we'd never had opportunities to test before. In the like industrial lubricants is one example, that we had struggled and tried with other sensors to make work, and there was a real need, but we didn't have there wasn't one on the market that could test those products accurately. So the tunable diode laser has really opened up a lot of doors for a lot of industries. It's able, like pharmaceutical manufacturing sometimes use organic solvents that have to be at a specific water activity level, but they didn't have a way to test and verify the water activity of those solvents, and that would be very expensive if they got the wrong amount and they try to make the pharmaceuticals, and it doesn't work out. So being able to have that was a huge innovation for us. Um, Now, I started in 2006, so 15 years ago, and it was within the first couple years that we first created our isotherm generator. So our isotherm generator was able to make uh, uh, um, the dynamic isotherms, what we call DDI isotherms. With a dynamic isotherm, you're not waiting for a product to come to equilibrium at a given humidity. Instead, you're seeing what happens while that product is changing in humidity. So most of the times when we're working, if we're making products, then it's going through a humidity change. We want to be able to see what's happening during that change, not just after it changed. And that DDI isotherm enables us to do that. We were able to find glass transition points with powders, for example, where the powder might start caking and clumping. We're able to see crystallization. Now with the vapor absorption analyzer we have now, it's our current isotherm generator. You can do both the dynamic isotherms and the static isotherms, the DVS. And so there's a lot you can do. And like I mentioned before, Zachary, you're the expert on this. So
I like listening to you tell it though, John.
okay. So anybody out there listening, if you want to learn more, Zachary's the expert. Talk to him. He will set you up. But absolutely, there's things that you can learn. For example, formulations. It's really great for the R&D teams. If you're looking to shorten your time and stop guessing and checking while you're mixing ingredients, like how much humectant do I need to add in order to get the results I'm looking for, then you can predict all of that with, and it's not just humectants, but putting multiple ingredients together and predicting final water activity, for example, or predicting shelf life based on packaging and the vapor transmission rate of the packaging. Easy calculations with an isotherm give you a good shelf life that's reliable. So rather than waiting months and months and months and doing tests over all of those months, or trying to do increased temperature to do accelerated tests that isn't as reliable, you can do it much faster and with much better results, better predictions, using the vapor absorption analyzer. So there's been so many innovations. How do I pinpoint the ones that are most important?
So it sounds like, just to summarize, maybe some of the big ones are the dew point sensor itself, the dynamic dew point isotherm method. We have the AQUALAB 3 and the ability to take that 1 minute reading, and then also the TDL technology. But what's the next big innovation? Is there anything that listeners should be excited about, or something that that's in the works that's going to come out?
Absolutely. If you want to be able to learn how to harness technology in order not only to predict, but in order to maintain consistency in your processes, regardless of changes in incoming ingredients, there's always there's always variability in incoming ingredients. There's always variability in ambient humidity and temperature. So there's a lot of things that influence your processes as you're doing a cooking step or a drying step, or sometimes even a moistening step, a spray dry step. We have innovation now that is able to use sensor technology, looking at the temperature. We have the ability sometimes to use the vapor pressure at different steps in the process, and using machine learning to actually learn your specific products and be able to maintain that consistency each time you make a batch, and have always coming to the right moisture levels after the process. So that's huge. I mean, that's going to save our clients so much money in lost batches, in low yields. It's just huge.
And if there's anyone listening to this episode who would like to learn more about Meter Group's instruments, or even talk to you directly, what's the best way for them to get a hold of you and learn more?
Well, you can always call me, 509-332-5521. Send me an email, john@metergroup.com. That's JOHN at METERGROUP.com. And you can also reach out to our sales team, sales.food@metergroup.com. You can reach out to our Scala team, support.scala@metergroup.com if you want to learn more about that software. There's so many ways, but go to our website, metergroup.com, and you'll be able to press a button on whatever page you're on and request information, chat with a support person, get connected with a salesperson. So talk with your application specialists if you have, and scientists like you, Zachary. So we have many resources where you can get information.
Great. Well, I just want to thank you again, John, for coming back for another episode. It's probably been 10 or 12 since we had you on last. I can't believe so many have gone by, but we definitely want to have you back again. So I will have to twist your arm another time and see if you'll come back and talk about a new topic.
Absolutely. Anytime.
I'm Zachary Cartwright. This is Water in Food. Find this podcast on Apple iTunes, Spotify, or wherever you listen to podcasts.